Let me know if you have any questions. Yeah, we're developing this website called BioniChaos.com. Check it out, provide your feedback. We are live streaming the development process on YouTube. So AI generated. AI generated. Let me know if you have any questions. Sorry, what's your question? Ooh. Yeah, check out the website, pop your questions in the chat. Let's close a few things. And there might be nothing happening in this stream. I'm also video editing at the moment. So we edit the longer streams if something happened. It's actually mainly AI talking. Some noise. Trying to do a review by AI, another review. There's too many of these reviews. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. Did you have a question? So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of Yeah, we're editing videos at the moment. Testing this thing as well. Testing this thing. Yeah, let me know if you have any questions. Let me know if you have any questions. Do a demo first. We used Notebook LM quite a bit in the past. It's quite expensive, but then you can access it for free essentially. Well, at least the audio generation. Yeah, not the search bit. Yeah, let me know if you have any questions. Like currently I'm editing a video where I was shitting to Notebook LM, not using it anymore. Uh, no, it's Notebook LM of interest. Probably not. Yeah, let me know if you have any questions. Except, what are you doing? There's a YouTube channel. There's a YouTube channel for that. I'll check out the YouTube channel. Well, I mean, we're streaming at the moment, so you are watching this live, or you need say again. That's a good question. That's the most popular videos we have on the channel. So it's, yeah, I think it's a journey. It's less of a, yeah, there would have been, yeah, there are like 1,000 videos. You can see which one's more popular or something. Let me know if you have any questions. If you have any good questions, go for it. Let me know if you have any questions. Let me know if you have any questions. Sorry, say again. Many questions. That's good. Well, we're live streaming on YouTube as well, so just so you know. People don't like being live streamed on YouTube. It's bizarre. Oh yeah, editing previous streams at the moment. If you have any questions, you can try record a heart rate. See how accurate it is. Let me know if you have any questions. Otherwise, we'll give you the AI treatment. Stream. Hi guy, how are you? Trying to bring someone live. Yeah, if you want to pop any questions in the chat, or probably have like a Zoom link for going live. How are you? Let me know if you have any questions. Let me know if you have any questions in developing this website live on YouTube. Did you have a question? anyone wants to help video editing. This video is 3 hours. No, do like up to 7, 8 to 10 minutes. Someone unsubscribing, that is great. This is awesome because it means someone wasn't actually interested. Actually editing this. Oop, won't even fit my... Yeah, I can't put it on the other screen. The editing business. To like adjust it manual or something. No, it doesn't fit. Doesn't fit that screen. Surely there's a way to minimize something. Minimize, minimize, minimize. Yeah, well, live streaming all the development process on YouTube. Let me know if you have any questions. Yeah, if you check the website, you know the name. Surely. Do let me know if you have any questions. Pop the link in the chat. Yeah, so it's streaming essentially all the development process. It's probably the most promising tool we've got so far. Let me know if you tried it out. Yes, we have an 8-minute. We have an 8-minute review. Let's bring Studio Live. Chat to a bot. See if it has any good ideas. What do you see on the screen? A screenshot website called BioniChaos displaying a real-time signal amplification that's live feed of a man along with the heart rate information. Is the heart rate information correct? I'm unable to determine if the heart rate information is correct. What are you talking about? It's either in the range. Can you look at the waveform? The waveform over here. Can you tell me if the waveform looks good or not? It's subjective if it looks good or not. Well, it's meant to be measuring the color change of the skin. Okay. Can we so we need to control for light and motion. Can you explain that? Okay, how about the signal quality at the moment? What can you tell me about that? Keep it short. The time series data is actually pretty good. Can you comment on that? Yeah, so the waveform is clear repeating pattern of the time series, but so it does look like a good signal, but the signal quality label only says fair most of the time. Why that might be the case? Okay, can you give me a summary of what we discussed so far?
We discussed the real-time signal amplification microscope website, which shows a live video feed of a man, his heart rate, and time and frequency domain graphs of the signal. We noted the waveform looks clear, but that the displayed quality is fair. potentially due to light and motion variations. I also mentioned that the heart rate information itself is not something I can verify for accuracy.
Yeah, the quality indicator for this case should be very high because you have that frequency spectrum locking in onto the heart rate. Can you explain all that?
The frequency spectrum indeed shows a clear and distinct peak in the heart rate frequency range. This indicates a strong and consistent heartbeat being measured, which generally correlates with a good signal. Although the label in the video says fair, the data in the frequency spectrum does suggest a reliable pulse detection. It's possible the quality label is based on other factors that aren't directly reflected in the clarity of the peak in the spectrum. Would you like me to explain how the frequency spectrum works in a bit more detail? This website showcases a fascinating technique for tracking your heart rate in real time just by looking at your face through a webcam. You can see the live video feed and the corresponding waveform and frequency spectrum, which show the subtle changes in your skin's color related to your pulse. While the signal quality was labeled fair in this example, the frequency spectrum did show a clear heart rate peak. If you're curious, you can try this website yourself to see if it can detect your own heart rate accurately. The address is bionichaos.com/face-blood-webcam, and I'd be interested to hear how it works out for you.
Yeah, okay, now the signal quality should be really high, but it's fluctuating quite a bit.
It seems like the signal quality is fluctuating between fair and good in the video as you move. This kind of fluctuation can be caused by slight movements of your head or changes in lighting conditions as they affect the webcam signal. The system is constantly measuring, so these small changes will be reflected in the quality label. Is there anything else you'd like to know about the display?
Okay, we have already 2.5 gigabyte in the browser. Let me know if you have any questions. Yeah, we are live streaming on YouTube as well. Can you ask a question about what you see on the screen? We have a YouTube channel we're developing live on YouTube. If you want to follow along, you're more than welcome. If you have any specific questions about the content, do let me know. Do let me know. Do let me know. Wait a sec. Hey, no, we're not doing like general tech. We're doing specific things. You can go visit the site. We're doing prosthetic arms. Well, generally, if you go onto the landing page, you should see Yeah, we're doing neurological tools, EEG, neuro tools, cardiovascular, so heart measurements, ECG, BPG, biomedical imaging, vision, hearing, EMG, so muscle artifacts. We'll skip that one. Simulations and modeling, doing some games, data analysis, AI. Obviously, everyone does AI these days, so that's not a surprise. A lot of signal processing. These are some of the tools we are featuring on today. So go smash that subscribe button, that like button. Unsubscribe if you're not watching. Now we're actually talking to Gemini. Can you give us a summary of the whole conversation and what we discussed so far?
We've been discussing the real-time signal amplification microscope website. We talked about the live video feed of a man, his heart rate display, and the waveform and frequency spectrum graphs, which show the signal derived from his skin tone. We also noted that the signal quality was fluctuating, but that the frequency spectrum showed a clear peak indicating a pulse. If you're curious about this fun way to track your heart rate, you can try the website yourself at bionichaos.com/face-blood-webcam and let me know how it works out for you.
Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform, sound simulations, muscle activation, webcam, eye tracking, prosthetic arms. So go check it out. Go check it out. Hey, how you going? We're doing all this on BioniChaos.com. You can check out the website. Tell us what you think. Doing a lot of different web application, Fourier transform. Let me know if there's any questions. Pop them in the chat. Especially if you checked the website first. If you checked the website, you would probably have some good questions. So we're live streaming all the development on YouTube and doing heart rate monitoring from camera. It's probably one of the better recent web applications that we have made. Prosthetic arm simulation. Doing a lot of optical illusions as well. Let me know if you have any questions. Otherwise, we were actually video editing. Actually, video editing takes forever. Video editing takes forever. It probably doesn't even make sense. There's a video on, so it'll be both EEG and ECG and PPG in one. So that doesn't make sense, does it? And let's see if we can. See if we can make it better somehow. Let me know if you have any questions. Developing this website called BioniChaos.com, and there is a YouTube channel by the same name, obviously, and we are live streaming all the development process. We are live streaming. Yep. That's right. Live streaming. Let me know if you have any questions. Beep, 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 beep. Let me know if you have any questions, especially if you visited the website. How you going? How are you? Let me know if you have a question. Maybe you can ask it in another language I might understand. Yeah, editing a video at the moment. So if you have any questions, go for it. It's a good time. There's some problem in that stream from a couple months ago with the sound. Shall we just get rid of it, or? In theory, you could extract the dystolic systolic from PPG. Can you? Does anyone know anything about it? Does anyone know? Can you extract the systolic dystolic upper lower heart pressure from PPG?
It's not possible to directly extract systolic and diastolic blood pressure values from a PPG signal alone, as PPG measures blood flow changes in the skin, not pressure. There are some methods that use PPG in combination with other signals or machine learning algorithms to estimate blood.
No, so just PPG alone. How about if I look at the dichrotic notch? Can I do it that way?
The bicrotic notch in a PPG signal is related to the pressure wave in your arteries, but it's not a direct measure of systolic or diastolic pressure. Its position and shape can vary based on different factors besides blood pressure, like arterial stiffness and even your posture. So, while it provides information about the circulatory system, you need additional data or calibration to get accurate blood pressure readings.
Okay, so what information does it provide? So if I measure the timing, doesn't that tell me something about the more about the heart rate activity? The time between the beginning of the signal, where the dichrotic notch is, and the end of the signal. Can you explain that?
Measuring the time differences between key points in the PPG signal, like the start, the peak, and the dichrotic notch, can provide insights into various cardiovascular parameters. For example, the time delay between the pulse peak and the dichrotic notch can be related to arterial stiffness and the location of blood pressure wave reflections. However, this doesn't provide direct numerical values for systolic and diastolic pressure. It gives additional information about the mechanics of your cardiovascular system. Do you want me to explain any of these concepts further? Is there anything specific you'd like to know about the current data?
So I shared the image with you. Can you see if the dichrotic notch is there or not?
Yes, looking at the waveform in the image, there is a discernible notch on the descending part of each pulse wave. It's located towards the end of the wave. Does this align with what you were expecting to see?
Can you explain where is it exactly?
It's located on the downward slope of the waveform, after the highest point of each pulse, and towards the end before the next pulse begins. It looks like a small dip or secondary peak in the wave. Does that make sense? Do you have any other questions about the information being displayed in the waveform?
Hey, can you check this image? Do you still see the dichrotic notch or not?
Yes, I can still see a dichrotic notch on the downward slope of each pulse in the waveform. It looks similar to what was visible in the previous image. Is there anything else you'd like to check about the waveform?
No, I really don't see it. What second is it? Where is it exactly?
Based on the time scale, the dichrotic notch appears somewhere between the minus 1.7 and zero point 0.0 second marks on the waveform graph. You can see it as a small dip on the downward slope of each pulse. Are you having trouble seeing it due to the waveform shape?
This is not it. That's not where the dichrotic notch meant to be, and it's not. You are incorrect.
I understand you're seeing something different. The dichrotic notch typically appears on the descending slope of the waveform, caused by the closure of the aortic valve. While the exact position can vary, based on typical PPG waveform shape, the feature in that region is the most likely candidate. Could you describe where you think the dichrotic notch is located? Perhaps we can pinpoint it together. Are you seeing a different part of the waveform as the dichrotic notch? If you can point to it on your screen, I can try to see it from your perspective. Or is there a specific reference you are using to identify the notch?